Sun Microsystems, probably the most commercially successful Unix workstation vendor there ever was. But sadly, as with all good things, unfortunately, it came to an end. So in this video, we're going to look at the last ever Sun SPARC workstation. The end of the line for all things Sun workstation. Well, with a SPARC processor in it anyway. As you can see from this absolutely gorgeous lump of tin in front of you, we have the Sun Ultra 45 workstation. The most powerful workstation Sun ever created. And although this example may be a tiny little bit battered and bruised, I'll tell you the story of how that came to be later, you can still see the sheer quantity of effort Sun put into this thing. And if you've watched this channel before, you know I'm going to use this as an excuse to explore some of Sun's history as well. This is not going to be the complete history of Sun video, that is coming one day, just not today. Today's video is sponsored by PCBWay, fine purveyor of printed circuit boards. Yes, that is what PCB stands for. If you have a design, you can upload said design to PCBWay's website, and in exchange for some monies, PCBWay will send you those PCBs back in the post. I mean, I guess they have to charge you. I mean, how else do they fund all these videos? I mean, everyone has to have a side hustle these days. Yes, but they're not just limited to doing PCBs, oh no, they offer a whole bunch of upload a design, get things back in the post services from 3D printing to CNCing, injection molding, you know, that sort of thing. I think the only thing you can't upload is a knitting pattern, although if you suddenly see them sponsoring half of knitting YouTube, you know that that's coming. I mean, personally, I really want to hear the phrase, "This cardigan is sponsored by PCBWay." Right, let's get a proper look at the Ultra 45. Now, as I said earlier, this is the last ever of the Sun SPARC workstations, well, Ultra SPARC. And Sun knew it was going to be the last one. This wasn't a surprise for Sun. The Unix workstation market had been, well, shrinking, and shrinking rapidly for quite a while. And there are a couple of things driving that. There was the ever-decreasing cost of PCs and their improving capabilities, and the fact that Microsoft had finally produced a, half-competent operating system in the form of Windows NT, that had later gone on to replace their entire Windows product line. And for those users that needed Unix, well, Linux was becoming ever-increasingly powerful and popular. So Sun knew this was going to be a last hurrah for the Unix workstation, or at least their Ultra SPARC based ones. So hence we get this really high-end case for a start. Now they did use this over a number of models. The case design was in the 45 and its single processor version, the 25. They also used it in a line of AMD-based Opteron machines that were again intended for the workstation market. So Sun really got their money out of the tooling they must have produced for this case design. And in a way, it really reminds me of a high-end Apple workstation from the time, the G5. Now, some were probably very much aware that this was not going to be a major seller in terms of numbers. After all, they knew very well how each previous generation of workstation had sold. So they knew that they were targeting an audience that really needed an Ultra SPARC based workstation because they were not ready to move on to something else. And they were also aware that that market would know that this was probably likely to be the last one that they were going to get. So Sun didn't exactly have to be budget conscious when they made this thing, as they knew unless they charged absolutely crazy money, they kind of had the market that there was going to be for this thing over a barrel. So they didn't need to do what they did when they introduced the first Ultra line of workstations, which is trying to grow their market by creating a more budget-conscious option. I mean, if I show you this Ultra 5 workstation here, Sun notably tried to get the costs of this thing down. So this is when they shift from using SCSI to IDE, as that meant cheaper discs, cheaper controllers. They also use pretty much off-the-shelf video cards, rather than trying to do their own thing like they had done with the Sun 4M range. It's also the point where they give up with their own bus design, so we no longer have S-Bus, but we moved to PCI, which was faster and more performant than S-Bus was, but it also marks the point where Sun stops trying to top what's available in the PC market, and just, well, joins the crowd. And that's because we got to the point where developing your own bus to attempt to be better than PCI was going to be hellishly expensive, so Sun, I think, pretty wisely chose not to go down that route. Now we should probably discuss the specs of this Ultra 45. For a start, it's a dual processor system, although they did release the 25, which is basically this machine, but single processor. I mean, to the point where it just looks like they plucked the components off the board. And it's got 8GB of RAM on board, which, even now that's a not particularly great amount of memory, but a reasonable amount for a PC. And this particular one was manufactured in 2007, so a coming up for 20-year-old workstation with enough memory that you could still run modern operating systems on this thing if they were, built for UltraSpark. Each of our two processors in here are UltraSpark 3Is running at 1.6 gig, which for the time in a workstation was an absolute beast of a CPU, and it's got two of them. Now I must admit, I do like the cooling and fan arrangement they've got for these CPUs. That is quite appealing and very well put together. In fact, the whole case design does have a sort of high-end feel to it. Everything sort of fits into place nicely. I/O-wise, we have a number of PCI Express slots. Again, Sun are not designing their own bus at this time, but they are using the latest and best that they can put on the board. We also have a number of PCI X slots as well, which is the 64-bit version of PCI, which is as high-end as PCI ever got. You did not see this in PCs very commonly, even in PC servers, as still most PC servers that were shipped were based on 32-bit chips rather than 64-bit processors, so couldn't really take advantage of the extra bit width in the bus. You can put 32-bit PCI cards in these 64-bit slots as well. Some provided these to be backwards compatible with hardware you might already have. Also, you could add stuff that doesn't have a PCI Express version yet, because we're still relatively new in the world of PCI Express at this point, so not every peripheral manufacturer has produced a PCI Express version of stuff that they have done before. Disk-wise, it can make use of SATA drives, and also SAS drives serial attached SCSI, which at the time were just that bit more performant and of course a lot more expensive. And Sun did in fact ship it with SAS disks because of course, as I said earlier, they're not trying to be that budget conscious. Graphics card wise, we have this ATI card with 64 whole megabytes of memory. I know that does not sound like a lot compared to the 8 gigabytes of RAM, but Sun did provide more powerful versions if you're going to be using your workstation for a lot of 3D stuff. Now this card is very similar to the sort of things you'd see in PC workstations of the time, with a bit of a difference being that the firmware ROM in this thing wouldn't actually work with a PC, and is intended to be used with Sun's Open Boot firmware, which we'll come back to later. I/O wise round the back, we've got two 1GB Ethernet ports, 6 USB 2 ports, 4 at the rear, 2 at the front, and we have an array of 2 whole audio connectors, one in, one out, with the same ports being mirrored at the front of the machine. None of these 60 connectors you might find on the back of a PC audio card. Oh no, we've not got optical digital out, for example. But Sun were including audio hardware in workstations where most PCs had a bleeper speaker and, that was it. Users of older Sun workstations will probably notice that there is no little mini DIN connector on this thing that Sun used for its proprietary keyboard and mouse standard. Yes, by this point Sun has finally embraced the USB keyboard and mouse, which means you can finally use a commodity keyboard and mouse with a Sun workstation. Although if you do, you will be missing a few keys that are quite important to doing admin on a Sun workstation, like the stop key for example. Which is why I ended up ordering myself a Sun USB keyboard so I'd have, the stop button. Also, I will note that if you power this thing up with my usual USB mouse in it, it is not happy. It really does complain quite a lot until you take the mice out and plug it back in again. I've never had my old net mouse do that on any other machine, so I assume when Sun implemented the USB stuff on this, it wasn't perfectly happy, or at least in the Open Boot firmware. Now, I spotted a particularly nice example of this thing on eBay when I wanted to purchase one, and it was going at a reasonable price and was being sold by a company that, professionally refurbishes workstations. And my assumption was this was not going to be the first time they'd ever packaged up and shipped one of these things, because they sold quite a lot of them in the past, and they know that this is not a light workstation by any stretch of the imagination, so you have to package this thing up pretty well. Now, I can only assume on the day my one got packaged that the guy who normally does it was on holiday or something, and they just grabbed any random passing muppet from the street and said, here's some bubble wrap in a box, get on with it. So when it arrived at my door, what I got was some soggy half-destroyed cardboard, kind of vaguely clinging to about 2 layers of bubble wrap, and a surprisingly unhappy-looking Ultra 45. So after a bit of a conversation with the supplier, they agreed to send me out a number of replacement parts for everything that got smashed to hell, and also discount the thing down a little bit for me, which meant I had to do a load of testing on stuff to check that the bits that weren't smashed were fine, and also remove all the, broken bits. So what I've ended up with is a not too bad looking Ultra 45, but some of the replacement parts were not as nice as the original parts were, well, at least before they tried to ship them. Now, one thing I did know when buying this thing is it didn't have any hard drives, which is probably a good thing because they would have just arrived as a box full of glass shards. but I did know I was going to have to put my own disks in this thing and install an operating system on it. So when I powered this thing up, all it had was OpenBoot, Sun's initial firmware. You can think of this as like the BIOS for Sun workstations, and OpenBoot has been the way you've got Sun workstations up and started since, well, at the very least from the early SPARC workstations. I don't know if when they were doing the Motorola stuff they still used OpenBoot. I've never had the fortune to play with any of the Motorola-based Sun stuff, or at least not before it had booted into an operating system anyway. One day I'd like to find myself a Sun-free machine. Now I must admit, I really quite like OpenBoot, particularly when you compare it to the likes of the PC BIOS. Now, OpenBoot was used a lot more widely than you might think. Why it's most famous for being the thing that makes Suns get out of bed of a morning, it was also used by lots of other companies that manufactured Sun-like workstations, for example this Tadpole SparkBook, which I took to Cambridge earlier this year for the Portable Fest. And I also completely forgot to film the thing because I was, having a good time, so thanks to both Pete and Tim for letting me use a bit of footage that they actually managed to record of it. Speaking about Cambridge, this November, Retrofest is happening again. Yay! And I'll be taking a bunch of Unix workstations, including this Ultra 45 and the SparkBook. So if any of you fancy having a bit of a nose at them, or all the other brilliant exhibits that are going to be there, including a box from Quantel you've probably never ever seen, then get yourself to the Centre of Computer History in Cambridge on either the 9th or the 10th of November, 2024, just in case you're watching this video long after it's been released. Links in the description below for tickets and stuff. Now, where was I? Oh, yeah. OpenBoot is not just limited to running on UltraSPARC and SPARC-based machines. There are in fact a whole bunch of PowerPC-based workstations that also used OpenBoot. And it's this idea of being able to use any kind of CPU architecture with OpenBoot that makes that ROM in the graphics card I mentioned earlier a little different to what you might think. Now, if you're familiar with the world of Macs and PCs, you probably know that ATI made graphics cards that went in PCs and was also used on the Mac platform as well. And the main difference between those cards was the ROM that's in the card. One was designed to work with a PC BIOS, the other one's designed to work with the boot firmware of an Apple. And the code in that ROM was compiled for the CPU architecture of the machine. So when Apples and PCs had a different CPU architecture, one was compiled for x86 and one was compiled for PowerPC, for example. The target CPU architecture not being the only difference between those two ROMs. But when it comes to OpenBoot, you cannot just compile the stuff that's in that ROM for SPARC or UltraSPARC, because OpenBoot works on other CPU architectures. And the expectation is that you can take a card that's got OpenBoot firmware on it and put it in any of the machines that can boot using OpenBoot. And the way this works is OpenBoot has a little virtual machine that it uses to execute the code from the firmware ROMs. So when you port OpenBoot to a new platform, you also port that little virtual machine as well. And then when OpenBoot starts up and scans through the bus and detects cards and pulls in the firmware ROMs and reads those, no matter the CPU architecture, OpenBoot can make use of that card. So for example, this graphics card has a ROM on that OpenBoot will open and read, and now it knows how to put stuff into the frame buffer so it can display stuff. And I could take that card and drop it into any machine that's got OpenBoot and a PCIe Express slot, and no matter the CPU architecture, that card will just work. For example, this PCI SCSI card here, exactly the same thing, OpenBoot firmware ROM on it. I could shove this in any of my OpenBoot machines where this card can fit. And to be fair, I have a lot more machines with OpenBoot and a PCI slot than I do PCIe. But you get the idea. And if you're, for example, a SCSI device, that firmware implements enough of a driver that OpenBoot can do all the things it wants to be able to do with a SCSI interface. So for example, list all the disks and devices plugged into it, do a diagnostic of those devices, read and write data to any of those devices. And this is the thing I loved about OpenBoot. I could do any of the diagnostic work I needed to with a machine purely in OpenBoot. I didn't need it to be running an operating system, because if it was broken, there's a reasonable chance it couldn't run an operating system. And I could use the same commands each time to do the same stuff. It wouldn't be that, oh, I got a different SCSI card in there, oh well, I gotta figure out how to use its BIOS screen, assuming it has one. The other great thing about OpenBoot, it was built with the idea of being able to remotely connect to it from the outset. So while it's happy to use your local keyboard and the frame buffer output to the screen, it's also equally as happy with you connecting a terminal to a serial port and doing it that way, or a modem. And in the 90s, having a modem plugged into it was an absolute lifesaver. So for example, I looked after a box in Wales and it had a modem plugged into it. When everything went wrong, I could still dial in and get into the OpenBoot firmware remotely and fix whatever had gone wrong with hard disks or replace hard disks or do whatever I needed to get that machine booting and running again, including completely reinstalling it if necessary. Now, although PCs did have some remote console type capability, most of that software required you to be booted into an operating system and to run the remote access application. For dealing with the BIOS, you kind of had to be sat at the machine for almost every PC. There were one or two that did have a way of doing that remotely, but those were very few and far between. With a Sun machine, anything from the cheapest workstation they had available to the most expensive multi-machine cluster supported doing this stuff just out of the box. Now, in order to make use of this machine or to do something more than just look at OpenBoot, I need to get an operating system on this thing. So, my plan was to install Solaris 10 because that was the OS that shipped with this thing. And amazingly, Solaris 10 still supported by Oracle to this day. You can actually pay them for extended support and still get support, which for an operating system that came out before this machine was released in 2007, that's kind of incredible. There are actually newer versions of Solaris. Version 11 is kind of considered the production standard version at the moment, or at least until Oracle just gives up doing the whole Solaris thing altogether, and that OS is supported on the Ultra 45 workstation. However, I am doing this as a retro project, so kind of wanted to have the OS it would have shipped with, or at least a version not riddled with security problems of the operating system that it would have shipped with. So I decided to go with Solaris 10. I would also need some hard drives, because remember, it didn't come with any, but luckily it will just take SATA disks. I don't have to screw around trying to do a SCSI emulator with an SD card or some weird compact flash thing like I do with almost every other project. So it was really nice to be able to just take a set of SATA disks I had lying around and, just use them in this machine. Well, almost. You knew it couldn't be that simple, right? Yes, I did need to get some disk caddies to go with the machine to hold the disks. Luckily, Sun seems to have not modified its disk caddy design over the last 30 years, save to sometimes make the front of them a little bit more flashy. So I could just find myself more or less any old Sun 3.5-inch hard drive caddy and slap in those SATA disks, pop them in the machine, and of course OpenBoot just detects that the hard drives are there and tells me that everything's working. In terms of getting the OS image installed on there, well, you can just download the ISO image from Oracle's website. It's still available. So I did that, burnt it to a DVD, popped that disk into the built-in drive, and told OpenBoot, boot CD-ROM, fully expecting the Solaris installer to come up. Is that what happened? No. What it did was make whirring noises for about 5 minutes, and then told me it had an error reading the disk. Now I wondered, did that mean, did I have an error burning the disk out? So I shoved it in another machine, did a check some of it. No, the disk is fine. I then checked, could I boot this thing using my trusty Solaris 2.6 CD? Nope. So at that point, I became pretty aware that the DVD drive in this thing was, well, a bit unhappy. To be honest, that's not that surprising. This drive was probably used once in 2007 to install the OS and never used ever again since. So over 15 years of inactivity has made this thing less than happy. And you might be thinking, well, you're screwed then, aren't you? Well, not quite. Again, we're going to come back to one of the really neat features of OpenBoot. OpenBoot can boot off more or less anything. So in the past, for example, it was used a lot to boot off a SCSI tape so that you could install your software from there. But from day one, it's also supported booting off the network so that you can install. So that was the option I was going to go for because I already had this thing set up so that I could install older versions of Solaris 2.6 on some of my Sun 4 machines. So it was not going to take me much effort to get a Solaris 10 image on there as well. Now I'll give you a bit of an overview as to how all this works because, well, we kind of like nerdy detail, and also, when I came to look up how to do this using Linux as the server side of this, there wasn't exactly a lot of material out there covering that. There are a few videos covering it a little bit, but mostly covering doing it entirely in Solaris on the server side, and well, most people just get one Sun machine for the first time and want to install it, so they're not going to have another Sun machine kicking around to be the server it installs from. So OpenBoot has always had the ability to type bootnet, which encourages it to boot off the network. And I'll explain this in a way that works from all Sun machines with OpenBoot, so from sort of early Sun 4, Sun 4M type kit all the way up to this latest modern stuff I'm showing here. Job 1 when you tell it to boot off the network is to get an IP address. Unfortunately, OpenBoot predates DHCP, so it does not use DHCP to get an IP address. Well, okay, the more modern stuff can, but the older stuff can't, so we'll just stick with doing it the non-DHCP way. Yep, in order to get an IP address, it uses something called reverse ARP. You may be familiar with ARP as the thing that allows an IP stack to work out what is the layer 2 address it wants to talk to over Ethernet from a certain IP address. So say your machine wants to talk to 192.168.1.1. If it doesn't know what Ethernet address that thing's on, it will send to the broadcast address a message that reads ARP who has this IP address. And the machine that has that will reply with ARP is at and its MAC address. And so the workstation wanting to send the packet can then write out the layer 2 Ethernet frame with the correct MAC address and the source and destination IP. Well, reverse ARP basically uses that same mechanism. A machine will broadcast out to the network, what is my IP address? And one machine on the network can reply with ARP, the IP address that's being allocated, is at MAC address of the machine that made the initial request. And our OpenBoot machine has now got itself an IP address. So in order to make that work on your network, you'll need a Linux box somewhere where you install reverse ARPD, and you edit the etc ether file, and you add an entry for the MAC address of the submachine that you want to install software on, and the IP address you want it to have. You then restart the daemon, and our OpenBoot firmware can now get itself an IP address. That's the first bit done. We now have to get a kernel that we can actually run, so there's something to execute. Now here OpenBoot makes a bit of an assumption. It assumes that the machine that replied with the reverse ARP packet is also running a TFTP daemon. So we have to install a TFTP server on that machine. OpenBoot will then connect to it and request a file name which is the same as the IP address it's been allocated, but written out in hex rather than in the normal dotted quad form. So that means on the TFTP server we need a file with that exact name that contains the correct Solaris boot kernel for our machine. Now, where do we get that from? Well, if we open up the CD image for Solaris and go into the tools directory, followed by the boot directory, we'll then find what looks like a normal sort of root of the filing system for a Unix machine. And in there we go into user platform, where we will find a list of subdirectories, one for each supported Solaris platform. So you'll see various Sun4 directories for the different Sun4 platforms, like Sun4M for the SPARCstation 10 and 20 for example, anything that uses the M bus architecture. And we'll also find Sun4U for UltraSPARC, and that's what our machine is. We're an UltraSPARC machine. So we go into there, followed by lib, then fs, and finally NFS, because we want to install this stuff over NFS. And there we'll find the file inetboot, which is essentially the boot kernel that allows you to do an NFS install. So we take that, put it on the TFTP server, and rename or symlink the file to be the IP address of the machine that's going to make the request in hex. So on the Ultra 45 machine, when we tell OpenBoot to boot off the network, it'll do the reverse ARP request, TFTP to the server that responded, download the file and start executing it. And that's our initial kernel, and that'll come and start bringing up Solaris ready to do the install. But that image doesn't contain the entire installer, just enough to get the kernel started, bring up an IP interface with the utilities to go NFS mount to share somewhere that contains the rest of the install image. But you may have noticed earlier when I described the whole reverse ARP process, it was a way of getting an IP address. It doesn't give you any other configuration information. It's not like DHCP, it doesn't give you a DNS server or a default gateway, or even worse, a subnet mask. Yeah, OpenBoot makes a bit of an assumption when it comes to subnet masks. It just assumes that it's a class C or /24 or 255.255.255.0 is the subnet. If that's not true for your network, this is not going to go overly smoothly. So if your network doesn't have that subnet mask, you're going to have to make a network that does. Now, clearly OpenBoot can't assume the other things it needs to know, so it does have another mechanism to get its configuration, and it's called bootparamd. Bootparamd is a configuration service, much like NFS is a file service, both from Sun and from pretty much the same time period. And luckily, bootparamd is still available for Linux. So we need to install that and create a bit of a config file where we tell bootparamd to hand some parameters to a workstation coming from the right IP address. And this is how we tell Solaris things like which DNS server to use, which default gateway to use. Heck, we can even override the subnet mask from being something other than a /24. But more importantly, from an install point of view, we finally get to tell it where the NFS root finding system is. So that means we do need a machine somewhere that's going to be the NFS server, and that hands out the root filing system, and as a separate mount, the install files for Solaris, and we specify where they are in this bootparamd file. Now, we can run boot paramd anywhere. OpenBoot does not assume it's on the same machine that gave it its IP address and where the TFTP server was. So it makes its request by hitting the broadcast address. And remember, it's assumed what the broadcast address is because it's assuming a /24 network. So we can run boot paramd on any machine we want to in that network, but we do have to hand it a little command line argument so it listens on the broadcast address, because by default these days, it does not. But assuming our daemon is running and listening on the broadcast address, it will respond to the request made by the Solaris kernel we loaded into OpenBoot. And the Solaris installer will now be told where the root filing system is and where the install directory is, so it'll map the root filing system, chroot into it, and continue to run the installer. Now again, your NFS server can be any machine on the network. I happen to use my little Synology NAS because that supports NFS and is a pretty easy place for me to dump the files. But pretty much any NAS supports NFS. You can install an NFS server into Windows, so you can use a Windows box to serve these files. Mac OS X also has NFS support. I mean, pretty much everything has NFS support. Heck, there are even NFS servers for DOS, if you're feeling excessively retro when it comes to installing Solaris. Now, unfortunately, the first time you boot Solaris and the installer, you can't just get in there and keep going. You have to boot it into single user mode so we can run the disk labeling tool. Because the installer assumes that you have a set of disks in the machines that already have Sun disk labels on them, which is like Sun's equivalent of a partition table. But if you just got blank disks, you don't have disk labels on the disks. So your installer would just start, detect the actual hardware disk, go, oh, there are no disk labels on that I understand, well, I've got no target I can install to, and exit the installer. So initially we have to do boot net space -s to get into single user mode. So when it all boots up, we just get a command line prompt. We can then run the format utility that lets us label the disks. Now, Sun disk labels are a bit different to partition tables that you might be used to in DOS, for example, or GPT, which is the partition type for UEFI BIOSes. In that, in Solaris, the OS does not go around just detecting what disk type it is, how many sectors, cylinders, heads, etc. that the disk has. It reads the Sun disk label that tells it, and then it treats that disk that way from then on out. So that means in order for Solaris to use a disk, something needs to write that label, and that's what the format command's there for. And you basically tell it how many sectors, cylinders, and heads the disk has. And then you write the disk label, and then Solaris can then get around to managing the disk even during the installer for doing the partitions, although you could choose to partition it at the same time that you're writing the disk label. The other option is to take the disks before you boot up your Sun machine, shove them in a Linux box, and use the fdisk command to write out the Sun disk label to the disk by initializing the disk as a Sun partition type. And this means it automatically gets right the sector, cylinder, and heads nonsense that you write onto the disk. Once you got that done, you can then power down your Linux box, take out the disks, shove them in your Sun box, power it up, and then you don't have to do the whole boot net -s thing to get to single user mode. You can just run the installer. Anyway, after labeling our disks, we can do boot net again. It will go through the whole process, get the IP address, TFTP, mount NFS, and start the installer. And we get a nice X-Windows environment where we can click through all the various install options like we would for virtually any other operating system, and then it'll get on and do all the installing. And finally, once it's installed all the software, the machine will reboot, and we've got ourselves a working Solaris 10 operating system that boots off the hard disks. Now, because I installed this with the latest version of Solaris 10 rather than the 2007 release, you're gonna see a lot of Oracle branding on this, because Oracle took over Sun when Sun went bust, so they've smeared their branding all over the Solaris operating system. It would be nice to have shown you all with the Sun branding on it, but I wanted an up-to-date version of Solaris 10 that have things like GCC available for it, so I could compile some stuff. So wherever you see Oracle branding, just imagine the Sun branding there. Apart from that, this thing doesn't really look any different. All Oracle really did was a logo swap. Now, once the operating system's fully booted, you see we're greeted by this graphical log-on environment, and that lets us choose the two different desktop environments they've got available. They've got CDE, which is kind of what you'd expect for a Sun machine. That was the default desktop from about Solaris 2.6 onwards. Before that, you had OpenWin. And you also have the Sun Java desktop, or whatever Oracle decided to rename it to when they dumped the word Sun. And that's pretty much the default desktop intended for this workstation, so that's the one we're going to use. Now, as it loads up, some of you will realise that looks sort of weirdly familiar but also a bit different, and there is a reason for that. Sun had really given up developing its desktop environment by the time it comes to the final workstation, but they didn't want it to just look like CDE. They knew it needed to look somewhat more modern. So what you have is the GNOME 2 desktop environment, essentially, with this dirty great big start button in the bottom left corner. Sun also initially shipped its Star Office with this, but also then later on made OpenOffice available with it as well, which is essentially the open source version of Star Office, if you like. Initially, Sun gave you Mozilla as the default browser, but as time went on, that moved to using Firefox. You won't die of shock to know by default it comes with a JRE ready to go, so you can run all that Java stuff. But they also made a pretty big deal of how they shipped this with their Grid Compute engine, which would later get renamed to Oracle Grid Engine. And this was a platform that allowed you to make use of all the Sun machines you had, you install it onto all of them, and you could distribute compute tasks across the grid. You can think of it as like a system for doing SETI or folding at home, but for whatever tasks you wanted to distribute across your machines. And the whole system allowed you to do things like nominate control nodes and shadow nodes so the network could continue to operate as various nodes went in and out of it. The idea being, as an organisation, you could get the most out of these very powerful workstations, and your servers as well. And there is actually an open source version of this still available today, known as Univia Grid Engine, which is basically a fork of the original Sun then Oracle versions. And in the marketing for these workstations, Sun really did make quite a big deal of this feature in its software. And if you're a research institution buying these workstations, yeah, this is a pretty good feature to be able to hand over to your computational biologists or physicists. You'll also not be surprised to discover that as it runs GNOME 2 for the desktop, it also comes with all the standard GNOME applications you would expect, like Evolution to do calendar and email, for example. And this makes it an extremely usable desktop, especially when you compare it to CDE, which by this point in time was looking extremely dated, and had not really had much improvement, as there weren't exactly many Unix workstation vendors left in town, and all of them were pretty much in the process of surrendering, so there was no enthusiasm for doing really any more development on CDE, and the open source world had really sort of taken over the Unix desktop market, so they really did just need to do what the open source crowd did. Hence our slightly different looking copy of GNOME 2. Now, the reason why people are buying these late stage and quite expensive UltraSpark workstations is they already probably had quite a chunk of software that was designed to run on Solaris and UltraSpark and Spark, and all those applications would still just continue to work and function, even though we have the GNOME 2 based desktop. In fact, applications that were targeting the 32-bit Spark processor and not the 64-bit UltraSpark processor, they would still just work fine too. As when it comes to user space applications, UltraSpark is extremely compatible with Spark processors. I mean, not for operating systems, but for user space code, very much so. Kernel mode stuff, completely different story. Yeah, you are not running an older version of Solaris that was released before UltraSpark was supported on UltraSpark hardware. Yeah, that lack of compatibility between Spark and UltraSpark hardware when it comes to kernel mode stuff really does allow the operating system to perform a lot better on UltraSpark, as Sun had way more experience developing operating systems and instruction sets when they came to develop UltraSpark. But for fun, I'm going to install some of my old Solaris 2.6 applications that we've, covered in earlier stuff, and you can see them up and running here. I also frankly want a couple of my GNU type tools, including especially Bash Prompt, and luckily these are all still built and maintained for Solaris, so I can just download them and not have to compile them all, and finally I can have a Bash Prompt on this thing. Yeah, why Sun didn't just include Bash with Solaris by default at this point, once they're using the entire GNOME desktop, goodness only knows, but yep. Still have to install Bash, so I do that, and yay. I also install Vim, because everyone needs a copy of God's own text editor. So how well does this thing perform? Well, for a machine released in 2007, this is a surprisingly usable machine still. The desktop environment doesn't feel particularly dated, and it moves, very snappily. Everything just runs pretty responsively. I can install and build, up-to-date modern software on this stuff, so I got a copy of SSH running on here, which means I can remotely log into other more modern machines and run a browser from there, for example. Now, I don't think I'm going to be able to build and keep up to date a modern browser on this machine. I think the likes of Firefox and Chromium make some assumptions about underlying hardware that this machine isn't really going to be able to offer. I think there are certain libraries it relies on that don't build or support Solaris anymore, or even in fact, instruction sets that are not really ARM or x86-64. Quite a few modern development languages, the tools are still available for Solaris, so I can get a fairly modern version of Python, for example, running on here, and I have started building PHP 8.4 on it. Unfortunately, that will have to be without the PHP JIT, because the library PHP relies on for doing JIT, well, it only supports x86 and ARM. But all in all, I'd say I'm pretty impressed with this. It still feels like a pretty modern machine. And for those wanting to answer the ultimate question, does it run Crysis? No, Crysis has never been ported to Solaris, or Spark or UltraSpark for that matter. But we do have two surprisingly powerful processors for the time period and OpenGL support, so, you know, we could probably build some 3D games, it's just commercially no one was ever going to. But this can make a very good all things retro workstation. For a start, I can run any Solaris application, including WABI, which means I can run any Windows 3.1 application, or Windows 2 app for that matter. And if I add this PCI card, well, now I've got an entire PC in here and I can run pretty much anything up to Windows 7 on this bad boy. Although not necessarily that stably because, you know, drivers. But yeah, I can run XP on it pretty reliably. I can also build myself a copy of UAE. Heck, in fact, some people already have. Same with BBEM for that matter. And with the ability to SSH out into other machines and run X11 apps remotely, you can actually stay on this workstation for a very long time and do, you know, most things you need to do. And have a lot of other retro fun whilst you're at it. Is getting yourself an old Sun workstation like this, well, or at least the most up-to-date one, and doing stuff with it, a good idea for everyone into retro stuff? Oh god, no, not even slightly. But for the Unix nerds amongst you who fancy learning, you know, something other than Linux, yeah, no, this could definitely be right up your street. You know, and if not a more up-to-date box like this, then, you know, maybe a SparkStation 10, 20, or IPX. SunKit has the advantage of it being one of the most widely sold of the commercial Unix platforms, so in the sort of second-hand retro market, well, there's a lot more of it just kicking around at reasonable prices. So if you're thinking, could I give it a go? Well, why not? And Oracle are still making UltraSpark servers running Solaris and selling them. I mean, I don't know for how much longer, but they are still currently doing it, so there is still a commercial value to this stuff as well. And there are still paid roles adminning this stuff. I mean, next time you happen to be passing your nearest COBOL programmer, ask them how their career's currently going, because you might be surprised to discover that they are far more employed than you think they might be. Well, if you got all the way to the end of the video, I'd like to say thank you very much for watching. Hopefully you enjoyed seeing the end of the era of the Sun workstation, and I look forward to chatting to you all about your Sun experiences down in the comment section below. If you liked the video, there's a special button that's there to indicate that fact, and if not, well, there's another button we probably won't speak of. If you'd really like to help the channel out in a way that doesn't cost any money, please hit the subscribe button, because it really does make a difference to whether YouTube can be bothered telling people that the videos actually exist.